So on 18, what we know is that radical 7 over 7 and negative radical 42 over 7 is on the unit circle. And for every point on the unit circle, we know all those ordered pairs, the x is your cosine and the y is your sine. So I'm asking you to find all 6 trig functions. So sine is just your y. Cosine is just your x. And if we have those, we can get secant and cosecant. So reciprocal of sine is cosecant. If you flip it, multiply radical 42 on top and bottom, and reduce to negative radical 42 over 6. Reciprocal of cosine is secant. So if you flip your cosine, you get 7 square root of 7 over 7, or just the square root of 7. And tangent. So 2 ways to think about tangent. You can think of it as sine divided by cosine, or y divided by x. So if we do that, radical 42 over 7 divided by radical 7 over 7. And a lot of people got confused on that. I've had quite a few come in and ask me today. So to divide fractions, you flip and multiply. So these drop. What you have now is negative radical 42 over radical 7. Because these are both under square root, you can just divide them, so you get negative radical 6. So then cotangent is the reciprocal, so negative 1 over radical 6, and negative radical 6 over 6. Is that okay? Do you guys want to practice real quick? So our degree measures, you know, it starts at 0. These are common angles, 30, 45, 60, and 90. This is 180. And remember, reference angle is how far you are from the x-axis. So all of these are reference angles of 30. These lines represent your reference angles of 45. And then these would be your reference angles of 60. So you're just doing 180 minus your reference angle. So 150, 135, 120. Here 180 plus your reference angle. So 210, 225, 240. And then this will be 270. Here 0 is the same thing as 360, so it's 360 minus the reference angle. So 330, 315, and 300. Are we okay with those angles? Now, in radians, 0 degrees is like 0 radians, or all the way around, you could say 2 pi. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. If your reference angle is 30, what are all the denominators? 6. When our reference angle is 45, the denominator is 4. And when the reference angle is 60, the denominator is 3. In the first quadrant, it's just pi. Second quadrant, you have to think it's smaller than pi, so the top is smaller than the bottom. So 5 pi over 6, 3 pi over 4, 2 pi over 3. In the third quadrant, it's more than pi, so the top is bigger than the bottom. So 7 over 6, 5 over 4, 4 over 3. And what's the pattern in the fourth quadrant? Since you're subtracting from 2 pi. So 6 times 2 is 12, minus 1 is 11. 4 times 2 is 8, minus 1 is 7. 3 times 2 is 6, minus 1 is 5. Then your ordered pairs. So you could think this is like the point 0, 0. So some of these are easy. If this is a circle of radius 1, what's this ordered pair? What's this point going to be? This would be, and this would be, and then we have our hand trick. So, fold in your 30. Remember, all these ordered pairs, it's cosine, then sine. So at 30 degrees, cosine is radical 3 over 2, sine is 1/2. And that is the same point for every reference angle of 30. The only difference is, in the second quadrant, what would be true? If you're applying point in the second quadrant, the x is negative. In the third quadrant, they're both negative. In the fourth quadrant, the y is negative. Okay, 45. Cosine is radical 2 over 2. Sine is radical 2 over 2. So in the second quadrant, it's the same except the x is negative. Third quadrant, they're both negative. And fourth quadrant, x is positive, but y is. Okay, pi over 3, so 60 degrees. Cosine is 1/2, sine is radical 3 over 2. So in the second quadrant, x is negative. Third quadrant, they're both negative. And the fourth quadrant, x is positive, and y is negative. So that's a complete order or unit circle with degrees, radians, and order pairs. If you can fill that out, then question 14 on is really just a matter of using that circle. But you don't have to have a circle. You can do it by hand. You just have to be able to do it without a calculator. So any question that I said without a calculator on the study guide, that means it's the first page of the test where I'm going to say do this page without a calculator. So unit circle is optional. If you want to fill one out, you can. But then when I ask you those questions, a lot of these we might know. Anytime it's a reference angle of 45, what's your denominator? So 45 is just pi over 4. If you filled out the circle, you can go to it and say, oh, 45 degrees, yep, that was pi over 4. When I say 270, you might remember it. You could look at your circle. 270, oh, that was 3 pi over 2. Now, if you get confused, you can multiply by pi over 180, but be prepared to do that without a calculator because I want to make sure you can convert. So you could always reduce those by hand if you had to. 240. Okay, you might be able to think about that. Well, that's in the third quadrant. What's your reference angle? 60. And I know anytime the reference angle is 60, the denominator is 3. In the third quadrant, the top is 1 more. And I can look at my circle. 240. Yep, that was 4 pi over 3. If I say 330, I could think, well, that's quadrant 4. Reference angle is 30. I know anytime my reference angle is 30, the denominator is 6, and the fourth quadrant, double minus 1, is 11 pi over 6. Or, look at my circle. 330 was 11 pi over 6. So I don't care if you use the circle, but make sure you can fill it out. So this is just going the other way. Anytime we see pi over 6, that is? Pi is 180. Make sure you put degrees on them. I know this 3 pi over 4. The top is 1 less, so it's quadrant 2. My reference angle, pi over 4, is 45. So 45 degrees in quadrant 2, 180 minus 45 is 135. Or look at your unit circle. Find 3 pi over 4. That was 135. 5 pi over 3. The top is double minus 1, so quadrant 4. Denominator is 3, so that means 60 degrees. So 60 degrees in quadrant 4 is 300. Or you know your circle.
Do you want us to put the quadrant in the reference?
You don't have to. I'm just trying to give you different ways you could think about it. Are we okay with those? What would you guys like for me to go over on here specifically? I mean, I'm happy to let's just run through all of problem 16 if that's okay, just because I think it's good practice. When you see pi over 3, what angle is that? Okay, so 60 degrees. Think about your hand trick. Tangent, square root of the top over square root of the bottoms. Whoops. So radical 3 over radical 1 is radical 3. I would want, when you got to these, like quadrant and reference angle, 2 pi over 3 is which quadrant? Reference angle, pi over 3 is like 60 degrees. So in second quadrant, we know cosine is negative. The cosine of 60 is 1/2. If you have your circle filled out, you can go 2 pi over 3, we know cosine is the x, negative 1/2, and we have it all there. Okay, if it's a negative angle, you have to add 2 pi first. So if you have negative 5 pi over 6, 2 would be like 12 over 6. So negative 5 pi over 6 plus 12 over 6 would be 7 pi over 6. What quadrant is 7 pi over 6? 3, because the top is 1 higher. Reference angle, pi over 6 is 30 degrees. In quadrant 3, sine is negative. Sine of 30, 1/2.
I got the same thing, but I just carried the negative to the answer.
You got lucky. So that's actually a property we haven't talked about with even and odd functions yet. It would work on sine, but not on cosine. So it's just luck, really. Another way to think about it is the negative means you're spinning down. So if you wanted to travel down 5 pi over 6, that would be another way to think about it. 7 pi over 6 is quadrant 3 because the top is 1 higher. Reference angle pi over 6 is always 30. In the third quadrant, tangent is positive. Tangent of 30, radical 1 over radical 3, which gives you radical 3 over 3. 11 pi over 6. What quadrant is that? Reference angle pi over 6 is 30 degrees. In quadrant 4, cosine is positive, so cosecant would be negative. It's a reciprocal sine. Sine of 30 is 1/2, so cosecant would be 2. All right, and negative 13 pi. So if it's a negative, you add 2 pi. Okay, if I add 2 pi, I get negative 11 pi. So we're going to have to keep adding 2 pi here. So negative 9 pi. Add 2 pi. So negative 7 pi. Add 2 pi. And if you keep adding, so you get negative 5, negative 3, negative 1. When you add it again, then it's pi. Now we know that's at 180 degrees. So if you think about your circle, that's right here. Cotangent is x over y. So negative 1 over 0 is undefined. Does that help? Can we go ahead and talk about 17 and just make sure we're all thinking along the right lines while we're heading this direction? So if I say 0 to pi over 2, what's that telling me? Quadrant 1. So 0 to pi over 2, that's quadrant 1. So you could use your circle. Cosine is the x. You know you're looking in the first quadrant. When is x pi over 2? And we can see right here, it's at pi over 4. I need to give the radians because this is in radians. If I say pi over 2 to pi, what quadrant is that? 2. So you can, it's harder to just look at the order pair, but we could think about reference angles. When is tangent radical 3? 30 is radical 3 over 3, so 60. And we know 60 is pi over 3. So in the second quadrant, top is 1 less, so it would be 2 pi over 3. All right, if you are between pi and 3 pi over 2. Quadrant 3. If you have a hard time thinking about secant, you can always think of the reciprocal. The reciprocal of secant is cosine. So that means cosine is negative 3 over 2 radical 3, or negative 3 radical 3 over 6, or negative radical 3 over 2. So when is cosine radical 3 over 2? 30 degrees. You can look on your unit circle to find it, or you can think, okay, 30 is pi over 6, and third quadrant top is 1 higher, so 7 pi over 6. This one, 0 to 2 pi, I'm saying every time it happens. So if you're thinking unit circle, you can just look at your ordered pairs and tell me every time the y was negative 1/2. Or if we think about quadrants, sine is negative in 3 and 4. Reference angle, when is sine 1/2? Degrees, which is pi over 6. So in the third quadrant, pi over 6, the top is 1 more, 7 pi over 6. And the fourth, double minus 1 would be 11 pi over 6. So do you guys feel like you can do those without a calculator? Okay. Let's hit problem 13. So we know the radius is 12.96. 18 seconds, what does that represent? 72 centimeters of belt going around a pulley. If it's going around the outside of the pulley, what variable is that? Okay, I want linear speed, which is v. So on your test, and this is a formula sheet I'm going to give you on every test, so don't write on it, I will collect it back. It's got a ton of stuff on it, but you're only looking at the very first column, your application formulas. So that's how it'll be presented to you. So if we're looking for v, which formula would be helpful?
A equals xt.
So I would prefer if you are writing down, even if you get the wrong answer, if you wrote down and identified your variables, I'll give you a point for that. If you write down the correct formula, I'll give you a point for that. It's a lot easier for me to give partial credit if I know what you knew going into the problem. So the more you can show me, the better. So this was 72 over 18, which is 4. 72 is in centimeters, 18 was seconds.
If it's the same stuff for both of the A and B, could we just identify it for both of them once?
Yes, that's fine. So B, we want the angular speed. Angular is our omega. So what formula could we use for it?
Theta over t, where you have to get theta.
Right, so we can do theta over t if we want to find theta. Or we could do V equals R omega because we found V in part A. Either one will work. So do you guys have a preference? Okay. So if I just did V equals R omega, so V was 4, R 12.96. So if we divide that. What does that reduce to? And that would be radians, and my time is in seconds. Is that one okay? Right, so the diameter of a Ferris wheel is 185 feet. Diameter means all the way across. So I'm using that to get my radius, which is just diameter divided by 2. So if you take your 185 and divide it by 2, you get 92.5. Okay, and 1 revolution. What does a revolution mean? But we always want to go to radians, so that would be 2 pi. So anytime I'm talking about a revolution, that's our angle. It's telling us we go all the way around. And that takes 15 minutes. My time is 15 minutes. Find the linear velocity. Give your answer in miles per hour. Okay, so first let's just worry about finding v. We have 2 options. V equals s over t, but I don't have s. Or v equals r omega, but I don't have omega. So we have to do 2 formulas here, either way. If I want to do v equals s over t, then what formula could I use to find my s? So r 92.5 times theta, which is 2 pi. So s is 185 pi. So then v is 185 pi over t, which is 15. And that reduces to 37 over 3. But let's think about our units here. R was in feet. So this is feet per, my time was in minutes. Okay, so now if I want to convert to miles per hour, so if I need to get rid of my minutes, they can go on top. I know 60 minutes is equal to 1 hour. If I want to get rid of feet, they go on the bottom, and I want miles. So 1 mile is 5,280 feet. So take 37 times 60 divided by the 3, and 5,280. It gives us a pretty ugly answer. If you kept it in terms of pi, I think it was 37 pi over 264. If you went ahead and just plugged it all in, it's 0.44 miles per hour. What else? Throw out some problems, guys. 1 through 11. Give me a few to work. What was the hardest? Number 9. You okay, McKenna?
Yeah.
Your hair?
My hair stuck in the chair.
These chairs are awful. Find the area of a sector. So area is what we are looking for. That tells me there is only one formula involving area. A equals 1/2 r squared theta. My angle is 2.3. It doesn't have a pi in it, but there's no degree symbol, so I know that is radians. And my radius is 6. So then we can just plug in 1/2 times 6 squared times 2.3. And if we put that in our calculator, I think it comes out to be 41.4. Area is always squared, so it would be square inches. What about number 11? Are we okay on that one? Point moves with an angular velocity of 3 pi over 2. What variable is angular velocity? Omega. The radius is 4 meters. Time is 25 seconds. Find the distance the point has traveled. What variable am I looking for? S. The distance it's traveled on the circle. That's my S. So I have 2 formulas for S. S equals r theta, but I don't have theta. Or V equals S over T, and I don't have V. So either way, we have to do 2 formulas. So let's say I wanted to do S equals r theta. How can I find my theta? 25. So if we multiply over the 25, theta is 75 pi over 2. So then we can do S equals R theta. My R is 4 times 75 pi over 2. That gives us 150 pi. S is a distance, so its unit is always like our radius. So it'd be 150 pi meters. Yes?
We put that as a decimal.
Sure. Yeah, any of these, as long as the decimal's equivalent, I don't care if you leave it in terms of pi or go ahead and work it out.
Number one.
Alright, so find the linear velocity. So linear velocity is v. Radius is 7 inches. Rotates 9 revolutions per minute. Revolutions per minute is giving me what variable? That's my omega. But the problem is, omega has to be in radians. So the first thing I need to do is convert that. So we need to get rid of revolutions, we want radians. So we know there are 2 pi radians in 1 revolution. So 9 times 2 pi is 18 pi. So now we have omega, and we were trying to find v, so now we can do v equals r. So you always have to get it in radians first. So 7 times 18 pi would be 156 pi. My units raised was in inches, time is in minutes. So an arc of length 4 feet. If I'm telling you the arc, what variable is that? No, S is 4. Cut off by a central angle of 60 degrees. So your angle is theta, but it has to be radians. 60 degrees is what in radians? Find the area of the sector. So, area is 1/2 r squared theta. We have theta, but we don't have r. So first we're going to do S equals r theta. So 4 equals r times pi over 3. I know a lot of people mess this up with the pi, so if you need to, think of it as you're going to multiply by the reciprocal. So if I take it times 3 over pi on both sides, then I get that my radius is 12 over pi. So it's 1/2 12 over pi squared times pi over 3. You're welcome to just plug that whole thing in the calculator, and I think it gives you 7.639. If you work it out, that's fine. It's 144 over pi squared times pi over 3. And that's how I got to my 24 over pi. And since it's area, that would be square feet. So either of those is fine. Is that okay? Number 8 should be 3 radians per minute. Trying to identify your variables based off the units. Area is always squared. So it'll be like square centimeters, square inches, square feet, etc. It's the only one that's squared. Radius and arc length. So I'm just going to say R and S. Those are just a linear measure. So centimeters, inches, feet, miles, whatever. Your angle will always be radians, degrees, or I might give you revolutions. But the thing to remember is
in those, you always change to radians. Then you have your rates. Your rates, your units are always like something per something. So V is linear, so it'll be inches per second, centimeters per minute, miles per hour. So it's a linear measure per unit of time. Omega is another speed, but it's talking about the degree or the angle. So it might be radians per second, revolutions per minute, something like that. But just like with theta, you always have to change to radians first. If I give it to you in revolution.